So let's try to understand how your skeletal muscle contracts. Okay, so this is usually very confusing for students. It's not actually. Okay, so this diagram looks, again confusing. So there are a lot of details you need to understand over here. When ATP binds, what it does, when does it detach, when does, cocking take place, what is cocking, and where is energy stored, when is inorganic phosphate going away, when is the myosin moving, all these, lot of confusion students have. So let me just clear all that for you. So this is your actin and this is your myosin. Okay, so in the resting state, which is right now what we're talking about, it is attached to it. So now ATP is going to come and bind to it. So this decreases the affinity of myosin to your actin. Okay, so when ATP is bound, that decreases the affinity of myosin to actin. So this, once the affinity is decreased, it moves away. Okay, so next what happens is once this moves away, so remember for it to move away, ATP should bind. So the factor that results in this myosin to come out of your actin is attachment to ATP. Next, hydrolysis of ATP takes place. Hydrolysis of ATP means inorganic phosphate and ADP is formed. So when inorganic phosphate and ADP is formed, and this hydrolysis is what gives it the energy to cock. What is cocking? You can see over here. Okay, so this is how you cock a gun. So here, using the energy from this person's hand, you cock it and place it in that position. So that is what happens over here. The hydrolysis will give the energy for it to cock. Okay, so when it cocks, this is how it looks. See, from this position, it went over here. Okay, so now in this state, what's going to happen is this inorganic phosphate is going to move away. Okay, so this will go up and attach, and then the inorganic phosphate moves away. So I hope that was clear. So initially it was at this level, ATP bound to it, and it moved down. Then hydrolysis took place, which made it cock to this position, and then it is going to go on top, attach itself to your actin again, and inorganic phosphate is going to go, and that will provide it the next phase for it to come back. Okay, so after cocking, it should come back and push it in front. So this is what happens. So you can see it has been cocked and then it's released. Okay, so when it's released, it's pushed it in front. Okay, next step, ADP moves away. Again, ATP comes back in. So now this is the resting state we started it. This is attached to actin. Now ATP is going to come and that will make it dissociate from that complex. And now again this hydrolysis takes place, and after hydrolysis this thing cocks. Okay, so just to help you understand what exactly is happening here, after this cocks it goes and attaches in front. So after that inorganic phosphate moves away, again it comes back. So every time this keeps moving in front like this. Mind you, this is not the end of it. Okay, there is more actin this side, more actin this side. Okay, this is just a diagrammatic representation. So as it moves this side, more part of this keeps coming, and this can keep on happening like this. Okay, so this is how it gets cocked, and after cocking, this is how the next part happens. Okay, again, this is how it's getting cocked, and after it gets cocked, it releases it, and each time the actin moves along. Okay, so I hope this was clear.